We've got two alkanes. It looks as if we've got nonane and 2,4-dimethyl-heptane, and it's asking us to deduce an expression for the relative state in general terms an alkane, a general formula, the general formula from an alkane, so it's CnH2n plus 2. So CnH2n2 plus 2, if you want to check that, 1, 2, 3, 4, 5, 6, 7, 8, 9 in nonane, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So you've taken the 9, multiplied by 2 to make 18, and added 2 to get the number of hydrogens, which is 20. So CnH2n plus 2. Deduce an expression for the relative molecular mass of an alkane in terms of N. So in terms of the relative molecular mass then, a carbon has got a mass of 12 and a hydrogen's got a mass of 1. So for every carbon has got a mass of 12, and then you've got N numbers of 12, and hydrogen's got a mass of 1, and for every hydrogen with a mass of 1, you've got 2N plus 2 with a mass of 1. So to work out the relative molecular mass in terms of N, a carbon is a 12, and you've got N numbers of cardinal atoms, so N numbers of 12, mass 12, and 1 times 2N plus 2, a hydrogen is 1, I've got a mass of 1, and you've got 2N plus 2 numbers of hydrogens. Expand those brackets, 12N equals 2N plus 2, 14N plus 2. Explain why non-N has a higher boiling point than 2,4-dimethylheptane. It's because it's a straight chain. The chains can pack closer together. If they pack closer together, there's more and stronger van der Waals forces. So non-N has more and stronger van der Waals forces between the molecules because the non-N molecules can pack closer together because it's a straight chain without branches. Give an equation for the complete combustion of nonane. So we've decided that nonane is C9H20. So C9H20 plus O2. Complete combustion. So combustion is reaction with O2. Complete combustion means it makes carbon dioxide and water. That means when there's a plentiful supply, lots of oxygen in the mixture. So complete combustion, carbon dioxide and water. If there's not enough oxygen, if there's an incomplete combustion is when there isn't a plentiful supply of oxygen, there's not enough oxygen, and in that case you would get carbon monoxide and water, or even carbon and water. But in this case we know there's complete combustion, plentiful supply of oxygen makes carbon dioxide and water. Let's balance it then. We've done that already, but I can show you how it was done. C9, the only place where the carbons go, the carbon dioxide, so I need a 9 in front of the carbon dioxide to balance the carbons. H20, so I need 10 in front of the H2O because 10 times 2 is 20 to balance the H's, and now I balance the O's. 9 times 2 is 18, add 10 is 28. 14 times 2 is 28, so we need a 14 there. Non-N is often found in fuel for jet engines. Combustion in jet engines produces pollutants such as nitrogen monoxide. Explain how nitrogen monoxide is formed. Well, the nitrogen in the air reacts with the oxygen in the air, so nitrogen and oxygen react together, and the reason that happens is because there's very high temperatures in a jet engine. Non-N can be cracked to form large quantities of propene. Crack means you take long chains and you break them up into short chains. When you end up with compounds with double bonds in them, hydrocarbons with double bonds in their unsaturated ones, then the type of cracking used is called thermal cracking. Thermal, it means you're using heat to break the long chains down into shorter ones, and you get these double bonds. The other type of cracking is catalytic cracking, and you don't get double bonds in that. You tend to get cyclic structures. The main use of propene formed from cracking is to make polypropene. So what you do is you draw out polypropene with a carbon-to-carbon double bond and a carbon going up, and then you break the double bond and join them together. So the repeating unit, you can see what's happened here. There's been a carbon-to-carbon double bond, so it's been propene with a carbon-to-carbon double bond there, and then the carbon-to-carbon double bond there in the propene, 1, 2, 3 in propene. The carbon-to-carbon double bond is broken, and a bond has gone either side to make a really long polymer chain of polypropene.